Can you all hear me? Yep. Okay, good. Some of you may have heard me speak before. My name is Doug Plata. I'm an urgent care physician in Southern California. And I am the president and founder of the Space Development Network. This is a free-to-join network of space advocates organized according to your interest. So if you have an interest in cooking, we have a food working group. If you have an interest in almost any other aspect of space development, we've got a working groups for that. And so you can visit developspace.info. This is an extremely extensive space advocate website that describes most every aspect of space development leading to settlement. So my topic today is meteorites for early metals on Mars. So let me just give you an overview. I'm going to go through the prevalence of, I use this nickel iron little acronym there, meteorites on Mars, the density of meteorites, how prevalent are they on the surface of Mars, as we have seen through the rovers, and then how drones, little helicopters, could be used to detect the location of individual meteorites, and then how with robots, little rovers, how those could be collected and sort of concentrated and brought back to the base, and then finally how those metals could be processed into various metal supplies, which then can be used to make parts. So that's the presentation there. So let's talk about the existence and prevalence of metal meteorites on Mars. So I estimate that there's, let's say, about 30 of you here, and let's say the average age is 50. So that's what, 1,500 life years represented in this room. Of all these 1,500 years, how many of you have ever in the wild walked across a nickel iron meteorite? Can I have a show of hands? Okay. I mean, we have walked, we've gone on hikes, etc. None of us in all those years. Okay. So let's talk about the prevalence on Mars. We've had several rovers driving, I think, a total of maybe about 60, maybe now it's a bit more than that, kilometers, maybe about 70 kilometers, that all of the rovers together have driven. And have they seen nickel iron meteorites in this relatively short distance, much shorter distance than we all have walked? And the answer is yes. Here's a picture of a nickel iron meteorite. It sure looks like one, doesn't it? Got those little pock marks from the entry into the atmosphere. But did they find just one? No. I mean, here's even more. So somebody here knows, why are they finding so many nickel iron meteorites? Where's the orbit of Mars? It's very close to the asteroid belt, right? And so no duh. Plus also the relative lack of weathering. I think things sort of settle up to the surface perhaps. And so, just like if you are in Antarctica and you're going along the white, snow and ice, and you see something black on the surface, a pretty good chance it's a meteorite. And so there's that. So I think the number, if I understand correctly, the number of meteorites that these our rovers have seen, out to a distance, is about the same number of kilometers that they've driven. So there's about 50 or so of the meteorites that have been seen. So what I did is I read a news report, just in a popular journal article, and about a researcher who had discovered these, and so they were quoting him, and so I Google his name, I find his email address, and I emailed him and asked him for a phone call. And you can do this, especially if like professor or researcher, you can just call people, and fairly good chance that they'll say, sure, I'll talk to you. And so I get him on the phone, and so I'm asking him all sorts of questions about this. I'm asking very specific questions because what I wanted to find out is how many kilograms of unoxidized metal are sitting on the surface of Mars for every square kilometer, okay? And so that takes several factors that I needed to get the information about. And so that came to, well, okay, what are the factors? So the factors are, how far have these rovers driven? How far, like with the mass cam, what distance can they reliably identify these nickel iron meteorites? And then what's the average mass of meteorites? And this was like guessing. You know, I came up with a figure, but I'm saying it could be an order of magnitude better or worse. But the number that I came up was 878 kilograms per square kilometer. Okay. So 878 kilograms sounds pretty nice, but a square kilometer is a pretty large area. So I was thinking, what could be done, because the amount of energy that it would take to turn this into usable metal is, you know, to melt it if you want just gross metals without purification. But if you try to extract metals from the metal oxides that make up the rocks, well, that's a pretty significant number of kilojoules per mole that you'd have to apply. And so if these things are just sitting there, perhaps it might be worth it to actually just go and pick them up, okay? So let's talk about plastics versus metals, because we love metals. For parts, we just love metals. It makes up all sorts of, you know, the chairs you're sitting on use metals, you know, all sorts of things. But on Mars, how prevalent is air? And if you locate yourself over a glacier, you know, just below the regolith, you know, how prevalent are these materials that you could use to make plastics? Well, it's almost unlimited amount of materials, okay? So what I would say is, as much as possible, when we're producing stuff locally, I'm talking things like, you know, furniture, or even, you know, housing, you know, the housing for equipment, that could be plastic, okay? But there's certain things that really need to be metals. And so what I'd say is 878 kilograms, if that number is anywhere near correct, that is not a lot of metal, but can we minimize the amount of metal that we need by choosing what parts we made, giving preference to the plastics? So what sort of things do we really need metals for? Well, things that have moving parts and they need to be particularly strong in interaction. So motors, gears, joints, like robotic joints, airlocks that you might need a really good seal. Can you have that sort of strength with plastic? Maybe you need metal. But you shouldn't be using metals for things like furniture. You could make that out of plastic. And the problem with habitat structures, normally we would like to use metal for habitat structures, but that's quite a bit of metal. If there's any way that we can go ahead and create pressure vessels out of plastic, we should try to do that. Okay, what about detecting the meteorite locations? And this is sort of my creative suggestion about how that could be done. Well, I'm sure most all of you are aware that this remarkable thing, we've had a drone helicopter fly on Mars. How can it fly when the air is so close to being vacuum? You know, it's 0.6% of the density of Earth's air at sea level. Well, what it is they got a couple of blades. I think the blades are sort of shaped a little different than what we'd have here on Earth. And then the tips of those blades are spinning so fast, I think the tip is actually going faster than the speed of sound here on Earth. It's spinning that fast. And they're able to push down enough air to be able to, you know, get this thing up. It's able to fly for a short distance. And it's just remarkable that we've got helicopters flying on Mars. And so I thought, well, could we use that technology? It's proven technology to go ahead and identify the location of these nickel iron meteorites. So here's sort of just a artist rendering of what that looks like. So here's my scenario, and that is we have a location where we have our base. And what we'd like to do is we'd like to go ahead and collect the nickel iron meteorites to the base for use. So what I'd say is we should go ahead and create sort of a honeycomb grid and start going in sort of an outward spiral sort of manner. And as we get out, let's say to this grid, then what happens is we fly the drone directly from our base to the center of that grid. And the grid needs to be, this hexagonal grid needs to be small enough so that when the drone flies up, it's able to have a field of view and the periphery is not too far, so that with a telescope, you can go ahead and be able to see that distance and reliably identify the spectral features of nickel iron meteorites. So after the drone flies out there, then it goes and flies up and scans down at some sort of angle, and then begins to pick out these nickel iron meteorites, the sun's reflection off them that's different than the other rocks. And so within that grid, it scans and it identifies the location of the rocks, records it, maybe broadcast it. Yeah, probably needs to broadcast it back to base. And then that is recorded. And then it flies to the next coordinate, flies up and does the same thing, okay? And it just keeps doing this, going around, in enlarging concentric circles to identify the location of these things until the region is identified where these nickel iron meteorites are. Then as we take a closer look, what we would do is go ahead and have send out surface rovers that will take sort of a least distance path between the meteorites along a somewhat linear path, and then collect all of those meteorites to one end, drive, pick them up, and take them to the end, and keep doing that until you have these 2 rows of clumps of these nickel iron meteorites. And then you send larger rovers that go out that are large enough that they could be able to go ahead and pick up those meteorites and then bring them directly back to base, so that you're collecting all of the nickel iron meteorites within that region. Okay, so once you have the meteorites, what can you do? Unfortunately, this thing is auto-advancing. I'm not quite sure where I am. So what can you do? Well, you take it and you do a process of metallurgy, and for many things, I think it may be just melting it, making it molten, and it would be how many of you have been up close to a nickel iron meteorite? Okay, like maybe 40% of you. So do you get the sense that that metal is pretty strong? Yeah, I mean the composition is such that by itself it's not a bad metal in its current state. So I think it could be used for many things, for like tubes for furniture, for I don't know, sheet metal, might be able to be of some use for like housing. You probably want to use plastic for housing as much as possible, but you can go ahead and melt it. If you want to go through like the Mond-Carbonyl processes, separate out the iron from the nickel, maybe use some carbon to go ahead and make some steel. There's certain applications that you need to go ahead and refine it further. So that's under the metallurgy category. Then after you melt it, then you pour it into blocks and molds, which are then machined. You roll it to make, there's like 2 types of rolling, where you have sheet metal, and sheet metal is incredibly handy. You cut it, you form it, you weld it, you can make all sorts of structures. You can go ahead and form the sheet metal into tubes and weld it to make pipes. You can extrude it and make bars. You can pull it and make wire. And then I should mention something there. I don't know that it'd be a really good choice for wire for electrical, but probably getting copper is going to be a challenge unless we can find a good place to mine copper on Mars. It's possible, but I'm not going to hold my breath that we'll find that place very early. So in that case, probably aluminum wires are a legitimate form. It can be done safely, but that's a whole different process than this. And then you can put it under molten metal under high pressure and spray it out and create a little basically metal powder that you can use to 3D print. And then you have all of these different ways of processing the metals into useful forms to create a variety of parts that you need to be able to expand your base without having to ship all these things from Earth. And so that's my presentation. I just sort of wanted to put it out there. I think many of you are not aware of just how prevalent nickel iron meteorites are on Mars. And so as you think about how we can really grow settlements, perhaps this is a piece of the puzzle that you might want to go ahead and take into consideration. And I'll open things up for any questions. I guess it's pretty straightforward. Okay, one question.
The prevalence of the meteorites, the kilograms per square kilometer. How long do you see meteorites as being the primary metal source?
That's a great question.
What kind of production volume do you get to when you need to switch that?
Yeah, I appreciate that. And for the people who are watching online, I'll just go ahead and repeat your question. And it's a great question. I probably should have included in the presentation. So there's a limited amount of metals that are easy, the low-hanging fruit. At what point I'm going to say in the growth of the population of the settlement, and I...
Tons per year,
Yes.
We don't know when that is year population, but what sort of the scale it gets to or beyond that.
Yeah, I think it's an open question. I mean, you could have opinions, but I imagine that probably if you're getting into the thousands of people, which might occur fairly early on, then I think that you are. I do anticipate plastics are going to be produced very early, and so your demand for metals will be reduced as a function of producing so much plastics. But I would say if you're getting into the thousands to maybe tens of thousands, then there does need to be an iron foundry that Elon Musk talks about. So I'd say this is why in my title was an early form of metals. Yeah. I mean, the question is could you be doing this all over the planet Mars and then be trucking back large amounts? Is that just an easy source of metals? Would we go that far to ship it over planetary scales? I'm not sure. Question.
Keep on saying use plastics when you can, because we do that on Earth. But wouldn't all the plastics have to be imported to Mars, whereas the metals are there?
No, I think plastics are CHON, carbon, hydrogen, oxygen, nitrogen. So carbon and nitrogen are in the air of Mars. Like 2% of Martian atmosphere is nitrogen, and obviously there's plenty of CO2 in the atmosphere. And then your hydrogen and oxygen, you can get the oxygen from CO2 in the atmosphere, or you can electrolyze the water. And there's continental, there's oceans worth of water short distance down in many places. So between that, then it's a chemistry process to produce polyethylene as a starter or the other polymers. Yeah. Orange shirt.
Of these meteorites, aside from the fact that Mars is near the asteroid belt, it also, for a very long time, has thin atmosphere that the asteroid is burned up, but you probably going through the Earth's atmosphere. And so you would have them, whereas you couldn't have them flying through.
Great point. I think that's worth mentioning. And for the people viewing, the comment is that because of the thin atmosphere, more of the meteorite would make it down to the surface. And that may be why there's also more. What I'd say is that the nickel iron meteorites, they do melt on the way in, and so it's sort of sloughing off. But they tend to have pretty good integrity, and so they do tend to make it in chunks to the ground. So I think probably it's due to the proximity. The asteroid belt is going to be a larger factor than than the other, I guess.
What kind of manpower would be needed to like realistically process these? In a time frame that would be beneficial?
Yeah, good, fair question. So I think that's a little difficult one to answer. Because it has to do with the degree of automation. And I don't mean artificially intelligent robots. I mean just systems that you feed it in and then, you got the sheet metal coming out sort of thing without any human intervention, except for maybe tending multiple pieces of equipment. I don't know. I think it's maybe a function of how quickly do we get large numbers of people on Mars. It may be that if that's a short time frame, then we won't have the time to develop this technology because on Earth, human labor is relatively cheap. On Mars, human labor is more expensive, but if you haven't spent the money and time to develop the more automated equipment, especially like small pieces that can be shipped, because nowadays, and we're all into industrial production of these metals, and there's no way we're going to ship some factory, that would be pretty expensive. So sort of in smaller batches, I think it would be, my guess is probably fairly labor intensive. And so I think we would probably look at maybe 20 years from now before those pieces of equipment, sort of lower mass equipment, is designed and produced. Just a guess.
I'm curious, your knowledge, have existing mining companies or companies that, for instance, would build foundry or whatever, have shown any interest in Mars at this point?
No, but if you are any of you are a wealthy owner of a mining company, please speak with me afterwards. I'd be glad to. Do we have an answer to that question?
Not that I'm aware of, yeah, so I haven't. I'm not playing out, but I'm aware. They're really what it's interesting. This real, it is, thank you, Doug, that would be, you can get this in their hands and convince them there's money in it. Yeah, that's all they're after. Maybe the private other come out with an approach. It's just not working for the balance sheet or.
Kind of is.
Yeah. But,
Yeah, and honestly, I guess myself, I'm sort of a skeptic in terms of the trillions of dollars to be made in space. I think mostly the production that's going to occur on the moon and Mars is going to be to reduce the cost, reduce avoid the high shipping cost. I don't really see any material substance of value that would attract mining companies that are dealing with billions of people on Earth. The market is just not that big. And unfortunately, that means that the development of these things either comes from NASA grants or maybe Elon Musk and the revenue from the Starlink 2.0. I think maybe that is the source of money to go ahead and develop these things. And I think the forcing function is the closer that we get to actually people being on the surface of the moon and Mars, and then creating that demand, that's what's going to go ahead and drive the development of these technologies. I think these technologies are not terribly difficult to develop, but there's just not a forcing function to get it. But with Starship, I think we are getting there pretty quickly. Good to see you, Colin.
Hello. So I don't really know that much about the makeup of meteorites, but did you ever look into other methods besides visually identifying them, such as like ground penetrating radar or any kind of metal detector that could, is the concentration high enough that can be picked up by a rover, or if there within a few feet of the main surface that would be identified as potential candidate?
I-
The density of a GPR, that can, you know, if it's within a certain amount of, you know, depth, it's still
It's,
identify it.
yeah, great question. I did think about the rovers driving over the surface with metal detectors, you know, that's only going to get a certain distance down. The only thing I have is the data that I have, and our data so far with these things has been surface observations. So I really can't say, you know, is there something natural in geology and in terms of how these things make their way to surface that most all of them are on the surface? It's possible, but I have no idea.
Finding them with vectors or VR research.
Yeah, but what I would say is on Earth, you do have rain and that's going to cover it. So I think I could imagine situations where it's below the ground. With Mars, you could also have it being covered by the light sand being blown around even by the low density atmosphere. So there could be that factor, but it seems like there's a lot of them poking out. So I think we have another question here.
Don't have a question, I have a little bit of answer, you know, for other stuff. I've had to
Thank you.
use metal detectors, trying to find broken off pieces in the product. And you only have a limited distance where you can detect it, whereas your visual inspection, you can detect much more farther away. So I think that would be a much more rapid technique. Yes, people hunting with metal detectors on Earth, but that's, as you say, that they're covered with vegetation, ground and everything else. And stuff as far as the meters being on the surface, I think it's something somewhere in Antarctica where, you know, the snow and the ice blows away or sublimates, and the only thing left is the meteorite. And I think that's the meteorites are going to, iron meteorites are much denser. Sand tends to blow around, blow away, the meteorites stay in place.
Interesting. Thank you. Are we done or? Are we done? Okay, well, thank you for your attention.